Hello everyone, this is Preeta. So today we'll see the chapter called Common Sense and AI. So I'll start with the what is common sense. So common sense is what people comes to know in the process of growing and living in the world, right? So in detail, it is the ability to analyze a situation based on the context using a millions of integrated process of the common knowledge. So the ability to use the common sense knowledge depends on being able to do the common sense reasoning. But here the huge task is to formalize the common sense knowledge for even a simple reasoning problem. So computers has a lack of common sense, but the goal of the common sense reasoning is to encode this implicit knowledge using a formal logic. So next we'll move to the qualitative physics. So anyone can predict what will happen in such scenarios, right? So we'll take the scenario, they can predict that the falling ball will bounce many times. For that, what they all need to know is the coefficient of the elasticity and the initial velocity of the ball. But there is a problem in this approach. It's mostly people were not knowing about the equations, and yet they are perfectly capable of predicting what will happen in the physical situations. Unlike the equations, people do not need exact numerical measures, right? They need only a qualitative descriptions. So to represent the qualitative information, the qualitative physics provides similar building blocks, ones which are more abstract and non-numeric. So no matter how states are represented, we need some way to reason about the information contained in them. So moving to the next. Common sense is identified as common sense knowledge and common sense reasoning. So common sense knowledge is about what everyone knows. So I'll tell you an example. So we all know that if we drop a paper into a flame, then the paper will burn, right? So it is a common sense knowledge. Obviously, everyone knows. So, and the common sense reasoning is about the ability to use the common sense knowledge. So moving to the next, we have common sense ontologies, where a computer program that interacts with the real world, it must be able to reason about the things like time, space, and the materials. So as fundamentally and commonsensically, the concepts may be as these concepts may be, but modeling them turns out to present some problems. We have three common sense ontologies. It's time, space, and the material. So in time, the most basic notation of the time is events. So events occurs during intervals over the continuous spaces of times. So an interval has a start point, end point, and duration between them. Plus also there were 13 possible relationships between the two time intervals, where we say like E is before, E is after, and E is met by, etc. So we can build axioms with the intervals. And science way of writing down one particular common sense theory of time. So next, moving to the space, the blocks world is a simple example of what we can model and describe the space, right? So the objects have a spatial extent while events have a temporal extent. We may try to extend some common sense theory of time, but space is actually a 3D and it has more relationship than those for time. So I don't think it is a good idea. So we have another approach is to view the objects and space at various levels of abstractions. We can view most printed circuit boards as being a 2D objects. So choosing a representation means selecting relevant properties at particular levels of granularity. The relations, like we can define the relations like inside curves, lines, planes, volumes, etc. The materials. So to describe the properties of the materials, we can ask if we pour a full bottle into a cup, then what happens? Uh, so so the liquids provide many interesting points such as like a space occupied by them, where we can define the properties such as like a capacity, amount, and the full. Full counts when if the amount equals to the capacity. This video we have seen about the common sense chapter. So thank you. Stay tuned for more.